Good afternoon, and thank you for bearing with us during this long presentation period. Our field project is entitled What Counts in Mobility? Our partner is the LivableStreets Alliance, and our group members are Ingran Lee, Sarah Saidoon, Andrew Schloss, Hawai Tran, and Jess Wilson.
So today in our presentation, we're first going to introduce our project partner, LivableStreets, and frame the issue of traffic modeling. After that, we're going to go into the goals of our project and how we conducted our research. We're going to explain to you what transportation modeling is and explore some of the problems that it could bring about. Finally, we're going to talk about our findings and recommendations.
Our partners at LivableStreets are Amber Johnson, the program director, and Ari of Sevet, who is a senior associate at the Institute for Transportation and Development Policy and a volunteer at LivableStreets. LivableStreets is a nonprofit transportation advocacy group based in Cambridge, which is focused on human-scaled transportation solutions and transportation accessibility as well as equity. LivableStreets recognized a problem with the model being used to forecast future transportation project volume and came to the Tufts team in the hope that we could research the model's assumptions and try to find the source of the problem, while at the same time questioning the use of the model to inform planning and policy making.
We'd just like to introduce to you some of the relevant actors involved in the greater Boston transportation process. We're also going to be using these acronyms throughout the rest of our presentation. First is the Central Transportation Planning Staff, or CTPS, which is the group of experts who designed and operate the model that is used in all the transportation projects in this region. The Metropolitan Area Planning Council, or MEPC, is a regional planning agency for Metro Boston. They work closely with CTPS to provide crucial land use forecasts and data that ultimately get fed into the model. MEPC is a member of the Boston Region MPO, which carries out transportation planning in the region. The Regional Transportation Plan is developed by the Boston Region MPO, which also guides the goals and priorities of planning for projects that depend on the model. The Travel Demand Model, or TDM, is a subset of transportation modeling that includes the CTPS model, which we'll cover later in this presentation.
So how many of you in this room or in this Zoom would like to live in the city on the left? How about the city on the right? So the focus of our presentation and our study is to discover how we can get from the city on the left to the city on the right. The city on the left is Los Angeles, and this is the I-5 interchange. Los Angeles is a city that was designed for cars. And on the right, we see the Embarcadero in San Francisco, which used to be a raced highway, but was converted into a pedestrian and transit-friendly boulevard. And the secret of getting from the left to the right is in the transportation planning process, which is the arrow in the middle. You may notice that there's a black box. That's the model. The model is a tool that transportation planners and engineers use to recommend transportation solutions. Many see it as a black box, and the goal of our presentation and our study is to open this black box.
So as Andrew mentioned, there's a gap between our vision for the future of transportation infrastructure and the tools that we use to achieve that vision. We know that modeling as a process is a bit of a black box. It's inaccessible and opaque, and not a lot of people understand it. We also know that models influence the outcomes of projects and that they tend towards overrepresenting demand for car travel. So we asked ourselves, what if transportation advocates better understood the model in order to better advocate for a sustainable multimodal future? We also, in this project, asked ourselves, how does the model even work? How is the model used during the transportation planning process? And what impact does the model have on the prioritization of transportation projects? And our goal is to make the process more transparent and accessible as a way to raise awareness and open conversation around how to improve the overall process. So we hope that this contributes to more transparency, more democracy, and ease in planning for an accessible, sustainable future.
The way in which we can achieve a more transparent, democratic, and sustainable future is by strengthening the link between the model and policy making, which we broke down to a three-step process. We first needed to understand the CTPS model and translate our findings and understandings into something that would be more accessible to the general public, not just planners and academics. The guiding questions that helped us better understand the model are, what is traffic modeling and where exactly does it fit within the planning process? We then needed to understand the transportation planning process so that we can have a better context for where modeling and public engagement fit in and how those two can better exist together. Here was where we were able to research and investigate some more about the mechanics of the model, such as assumptions and data, and how that information is collected and ultimately used. Next, our interviews and independent literature reviews then tie together all that we've learned so that we could offer some recommendations that can hopefully improve the planning process and suggest ways in which we can move modeling forward so that we can meet our state and city transportation goals.
Our main methods are literature review and stakeholder interview. In general, we learn about the mechanism, direction, and current critiques of the four-step model in a broad sense through literature review. And we learn about the specific CTPS model and its application in the Boston area through interviews. We also study the current transportation trends in the Boston area, as well as current and future planning goals in the region to understand how model reflects these goals. And to achieve our goals, we need to figure out what is the travel demand model, especially the CTPS model that used in Boston area. CTPS travel demand model is based on four-step travel demand model, which is the dominant form in conventional traffic modeling. Basically, it consists of trip generation, trip distribution, mode choice, and trip assignment 4 steps. Trip generation is trying to figure out how much trips each traffic analysis zone will create and attract. This is related to the demographic information like age, employment, how many vehicles and bikes people have. It also related to the land use, like the residential land will produce many traffic and commercial land will attract many traffics. Trip distribution is trying to predict where will people go. Often in this step, people will use gravity model as an assumption. It assumes people's travel time and costs will increase, then the number of trips will decrease. Mode choice will determine the proportion of each trip, transportation mode for the total trips. In other words, it will answer how many trips use cars, how many trips use public transit or other modes. And the final step, trip assignment, is to predict what roads will be used. It is based on the assumption that people will minimize their travel costs by choosing a better route.
Model output is only as good as the model inputs being fed into it. So poorly collected, outdated, inaccurate, or inputs and assumptions will result in a bad model prediction. We can see here that the model has various inputs. And if only one of the inputs are incomplete or outdated, the accuracy of the output is diminished. Second, we can see that an existing bias of the current model prioritizes automobile transportation, which is given weight over human-centric modes such as biking and walking. This is an issue because current planning goals, such as reducing traffic facilities, are overshadowed by these biases. Next, we see that the model output is an imperfect prediction because we can't predict the future. However, it is taken as an objective truth to support policy decisions, and it often goes unquestioned. The aggregation of these biases, inaccuracies, and in some cases false truths leads to decision-making that may or may not reflect reality and actual transportation goals in the region.
So the Longfellow Bridge redesign is one way that this inaccuracy recently manifested in a local planning project. The CTPS model was used to forecast traffic volume, and as you can see, when comparing the forecast for inbound vehicle counts and outbound vehicle counts, the with actual post-construction counts, the CTPS model overpredicted for vehicular traffic by well over 50%. This overprediction for car usage resulted in a plan that did not include adequate infrastructure for bikes or pedestrians. And Livable Streets, in coalition with other advocacy groups, were successful in fighting for wider sidewalks and the inclusion of bike lanes, but point to this as a general lost opportunity for carrying out our state's overall vision for more human-centered, multimodal transportation infrastructure, which has huge implications for other projects that are under construction at the moment. So the analysis, we performed an analysis on the literature review and the interviews that we conducted, and we get much more into the specifics of the main assumptions and inputs and strengths and weaknesses of the model in our report. So we won't get too into that in this presentation, but I'll quickly touch on that. We uncovered some of the inputs and assumptions that are used. Some inputs include data from the decennial census. Assumptions we found are mainly pretty dated, that the car is the preferred vehicle choice, and that the connections that we make between household size and income and trip generation and mode choice are pretty out of date and don't really reflect the kind of sophistication of how people make decisions on how to move and where. A strength is that it's seen as a tool to provide data on which to make decisions, and these transportation projects are huge. They need a lot of money and a lot of time to be carried out. So it is important that decisions made about these projects are based on data and on a decision-making process. Weaknesses, as we've covered, include that there's a lot of potential for inaccuracy and for the results to be skewed by interpretation. And ultimately, no one can predict the future, but all of this information led us to question if the model as it exists today is the best tool for to plan for new transportation infrastructure. And most importantly, models are imperfect tools. And just like statistics, model forecasts can be subject to interpretation, and errors in interpretation lead to incorrect conclusions. This means that a number can be used to justify road expansion projects or doom transit-oriented projects. Just a note on data, it's a big thing that came up in all of our interviews over and over, that no matter how much you tweak an algorithm, if the data is biased, the result will be biased. And our interviewees emphasize the need for better understanding how people move in a rapidly evolving region. This includes bicyclists, pedestrians, but also understanding how pressure from the housing and employment market are causing people to move.
Our interviews revealed the nature of the relationships among some of the actors involved in the transportation planning process from beginning to end. It first begins with a kind of client, which is usually a state or federal transit agency, such as MBTA, MassDOT, or the Federal Highway Administration. They identify the problem. CTPS acts as the consultant and uses the model as a tool for analyzing the information that can lend credibility for moving forward with the project. MAPC, as we've mentioned, provides the data and forecasts needed to run the model. The local municipals become involved later in the process after the model has already produced its predictions, and one of their roles is to engage their communities at town halls and other forums. The interviews confirmed our initial hypotheses that emerged from the literature review and consultation interviews. The community input comes too late in the planning process to be effective. As we understood more about the CTPS model, we realized that because it was first created to address highway expansion, it's inherently too car-centric. There isn't a way to collect complete or near complete transit and bike ped data. These inaccuracies often lead to the false conclusion that transit and bike ped projects would be underutilized. However, all the stakeholders that we interviewed were very interested in our findings and were passionate about moving toward a better future for transportation planning. Although some of their perspectives are in direct contrast with one another, many agree that we need to find a better way to incorporate data for more sustainable modes of transportation. They also would like to see a more iterative process. Presently, the model predicts a future based on a no-change assumption. Obviously, this is not the case in the real world, so there needs to be a better and easier way to modify the scenarios based on changes and predictions happening in real time.
So in addition to implementing an iterative process into the model, in light of the current COVID-19 pandemic and the new stresses placed on our transportation system, we thought that integrating public health more robustly into the model is really imperative. The Commonwealth of Massachusetts already has the framework to connect public health and transportation, and this would only complete that. Also, we noticed that there's a huge data deficit for urban, bike, and pedestrian data, so we need to work for and fight for better data in these fields to ensure that we have more accurate outcomes from the model. Finally, we focused on the planning process itself. We realized that community empowerment and engagement throughout the planning process, especially at the beginning of the planning process, were vital, so this needs to be improved. One major takeaway that we have from our study is that you too can understand the role of modeling. You too have the ability to fetch the bolt cutters and open the black box so we can better understand and engage in this process. And finally, we'd like to implement more qualitative analysis into the transportation process.
So in summary, travel demand model is important for transportation planning. It provides the rational basis to decision-making to some extent, but it is an imperfect tool. Its results often overrepresent automobiles and short in counting urban and human scale data. So we call for better tools to complement the model and collecting more comprehensive data. We hope our report can help people better understand the travel demand model. Like none of us has engineer background, but we kind of have a comprehensive understanding of the travel demand model through this research. So we believe that the traffic model is not a black box. Lay people and the public can definitely walk into it and understand it. And only by understanding the mechanism and the data of the model can we make better use of it. And we also hope that the model's prediction will reflect reality more objectively and be closer to our vision of the future, transportation, and through deeper community engagement. For the future planning, we need to rethink about what is the priority of our transportation. The world is not static, as many examples such as climate change and today's coronavirus have shown us. And do we still need to insist to the traditional ideas of transportation development, or reordering our values to determine the new goals of transportation is a better choice?
And as you can imagine, this inquiry led to a lot of other questions that we didn't have time to explore in this report. But we'd love to just leave this to the audience for folks who are interested in exploring this more. So some of the areas for further research that came up for us were around just this question of how do we even get better data? What are the implications for using big data to collect information on cyclists and pedestrians and other modes? Are there risks with security, privacy, and surveillance? Another question that came up was, is there a viable alternative to modeling? Are there other cities that aren't using models that are coming up with innovative and exciting ways to plan for sustainable transportation? And if so, how are they doing that? Of course, it came up a lot that there's a large financial barrier to taking risks and planning for new and innovative projects. So we would love to see someone explore the need for supporting the growth of state transportation budgets. And then, as previously mentioned, how can we take an environmental or public health focused approach to planning for a sustainable and multimodal future? So that's the end of our report. Thank you very much. And we now have time for questions.